Okay, this is equilibrium constant part 2, and this problem is a little bit more advanced than the one we did in the previous problem. Again, it's asking for the value of Kc, so it wants to know what the equilibrium constant is. It gives me a temperature of 500 degrees K. I have a volume of 1.500 liters. This time it says it was filled with, and then when this mixture came to equilibrium. So because I have those two statements, I have to use the ice table. So now we're doing the full type of problem. So I have an ice table. So I was filled with 0.1500 moles of CO and 0.300 moles. And unless it states that I have a product, my product's going to be 0. My change for the two reactants, the things on the left, is going to be the negative because it's a reactant, coefficient, which is 1, x, negative, coefficient 2, x. The product is going to be positive, coefficient is 1, so this is just x. And it says when this mixture came to equilibrium, it contained 0.1187 moles of carbon monoxide, so that means this is the one that I have the equilibrium for. So the next step is to determine what C is. So I'm going to take the one that has both I and E. And so the equation is I plus or minus C is equal to E. So I have 0.1500 minus X is 0.1187. I subtract the 0.150 from both sides. So I have negative X is going to be 0.1187 minus 0.1500. Negative X is going to be a negative 0.0313. You can multiply both sides by -1. You can divide both sides by -1. It doesn't matter. I'll just say divide by -1 by both sides. So X is 0.0313. So now that I have this, I want to put this back in here. 0.300 minus 2 times 0.0313 gives me 0.2374 moles. This is just X, so this is 0.0313 moles. Now I have to change these into concentration by dividing by the volume. So I'm going to divide all three of these by 1.5 liters, which was the volume given. And this one becomes 0.07913. This one becomes 0.1583. And this one becomes 0.02087. And all three of these are now molarity. So I'll write the equilibrium constant expression. So Kc is going to be the concentration of CH3OH divided by the concentration of CO times the concentration of H2 squared. So when I put in my numbers, I get 0.02087 divided by, parentheses, 0.07913 and 0.1583 squared. That's probably the number one mistake that students make, is they forget the fact, well, I put the square on the outside there, didn't mean to, that the square up here, need to carry it down here. And when I do this math, I get 10.5. And again, for the units, I have a molarity over molarity times molarity squared. Those two cancel out. So my units become the m to the minus 2. Okay, and so that's how you do this problem. I suggest that you pause it and try to do the next problem, this problem here, before I work over it. But I'm going to go ahead and move on. So I have 2 moles was placed in here, so this means that this is an I, and I have 2.00 moles. I have a volume of 80.0 liters at 200 degrees, so I have a temperature of 200 degrees C. The carbon dioxide concentration was 1.88 moles, so that means this is going to be my C, this is my E. Nitrogen dioxide is this one, so it's 1.88. So again, I have a reactant. They want to know what Kc is. Okay, so I'm going to fill out my ice table. Any products not specifically mentioned are 0. The reactants are minus 2x. The products are 2x and x. Again, this is the one that I have the I and E for, so it's going to be 2.00 minus 2x is equal to 1.88. So negative 2x is equal to 1.88 minus 2.0. So negative 2x is equal to negative 0.12. X then is a negative 0.12 divided by a negative 2 to give me x to be equal to 0.06 moles. So now I plug this in, so 2 times a 0.06 is 0.12 moles. This is just 0.06 moles. I need to change these all to molarity by dividing by the volume of 80.0 liters. Oops, that was there. And 80.0 liters. When I do this, I get 0.0235 molar. I get 0.0015 molar. And I get 0.00075 molar. My equilibrium constant expression, Kc, is going to be the concentration of NO squared times concentration of O2 divided by concentration of NO2 squared. So I plug in my values. So I have 0.0015 squared times 0.00075 divided by the 0.0235, again that one's squared, and I get a value of 3.06 times 10 to the minus 6th. The units are going to be molar squared times molar divided by molar squared. So my units for this one is molar. Okay. Alright, so this will be the end of part 2. When we go to part 3, we're going to look at another equilibrium constant, which is Kp.